Today we're going to look at section 7.1 called the law of sines. We are going to use the law of sines to solve oblique triangles. So the law of sines and its derivation. So an oblique triangle is a triangle that does not contain a right angle. When we have an oblique triangle, we have two cases to consider. The first case would be that the triangle could have three acute angles. Because remember, in a triangle, three angles have to add up to 180. So if they're all less than 90, we can get that to happen. Or the triangle could have one obtuse angle and two acute angles. Once again, acute means less than 90, but then obtuse means it has to be between 90 and 180. So, what is the law of sines? The relationships among the sides and the angles of right triangles defined by the trig functions are not valid for oblique triangles. One relationship that does exist among the sides and the angles of oblique triangles is called the law of sines. If A, B, and C are measures of angles of a triangle, and then A, B, and C are the lengths of the sides opposite these angles, then A over the sine of A equals B over the sine of B, which equals C over the sine of C. The ratio of the length of the side of any triangle to the sine of the angle opposite that side is the same for all three sides of the triangle. So when it's saying, if I'm looking at a picture, so say angle A, B, and C. So those are always the capital letters are the angles. Notice then with A being down at the left, across from it, that's side A. And so that's written with a little angle, with a little a. The side across from B is little b. The side across from C is little c. So that's what it's talking about. So let's talk about how we could actually prove the law of sines. Obviously, you can just take us for our words, but we kind of want to explain where this is coming from. So we're going to look at this picture here. When we have an altitude of length h from one vertex of the triangle, we then have right triangle trig. Okay, but prior to dropping that altitude, triangle ABC did not have any right angles, and so we weren't able to think about SOHCAHTOA. Because remember, SOHCAHTOA, you have to have a right angle. You have to have right triangles. But by dropping that altitude, now we have that right angle at D. So if I'm looking at, it says sine of B. So notice that angle B is over here at the far left, or sorry, the far right. Opposite would be H, if you're thinking about the right triangle, BCD. And then the hypotenuse would be A, because sine is opposite over hypotenuse. So taking that and solving for H equals A times the sine of B. If we look at that other right triangle, because even though the right angle is only written on one side, technically there are two right angles. So I'm looking at another right triangle, triangle ACD. If I focus on angle A, the sine of angle A is equal to H over B, because once again, H would be opposite, B is the hypotenuse of that small right triangle. So once again, if I wanted to manipulate that around and solve for H equals B times the sine of A. So notice that in both of those equations, we have H equaling something. So what can we do with that? Well, when they both equal H, we can then just set them equal to each other. So notice that A times the sine of B equals B times the sine of A. So then if I wanted to manipulate this equation around, we have to make sure we're doing the same thing to both sides. So if we divide both sides by the sine of A times the sine of B, notice that on the left, there's a sine of B in both the top and the bottom. So because that's all multiplication, that would be able to reduce. Same thing on the other side. There's a sine of A in both the top and the bottom. So that would be able to reduce. And notice that A over the sine of A equals B over the sine of B. So we just proved that with two ratios, but in that definition, remember, technically you have three sides of a triangle, so we could do that one more time with that third set of sides. So, solving oblique triangles means finding the lengths of its sides and the measurements of its angles. The law of sines can be used to solve a triangle in which one side and two angles are known. So that means there's two situations that we can think about with that. If you have one side and two angles, you can either have the side not in between those two angles, so it would be the situation side, angle, angle, or you could have that side what we call included. So it'd be angle, side, angle. So let's dive into some examples here. So I'm giving you this picture. It says solve the triangle with, notice how A is capitalized, so that means angle A. That's 64 degrees. C is 82 degrees, and then that little c represents the side, so that side C is 14 centimeters. We are going to round side to the nearest tenth, okay? So notice that if they want us to solve the triangle, essentially we're finding the missing pieces. So they are giving us three things and we are finding the other three. So they have given us two angles and a side. Notice that side is not in between the two angles that were given. So this is the situation of side, angle, angle. Okay, so we have one side, two angles, the side is not included. So with that being the case, notice that the missing angle that we don't have is angle B. That's something that we can find right away because regardless of what kind of triangle you have, I mentioned it previously, three angles of a triangle have to add up to 180. So if I'm taking 180 and I subtract away the two angles that were given to us, we can then clearly see that the measure of our angle is going to be a 34-degree angle. So there's my first missing piece. The rest of what we have to find are the two missing sides. We don't know what the length of A is, and we don't know what the length of B is. So let's start with finding A. This is where we are going to use the law of sines. So because the only side we have is 14, notice that we are going to always need to use that side, and that means we need to use the angle that is relating to that side. So because that's side C, we also need angle C. So we set that up where we would have the side on the top over the sine of its angle on the bottom. So we'll have 14 over sine of 82 degrees. This is going to equal, because I want to find the side of A and sides go on the top, we'll put that on the top. That means that the angle that we need is the angle that is directly across from that side, which is angle A. So on the bottom, we want the sine of 64 degrees. Notice that what we've created is a proportion. We have a fraction equals a fraction. And so when that is the case, we cross multiply. So I'm going to multiply the 14 and the sine of 64 degrees together, and then we will set that equal to the side of A times the sine of 82 degrees. If our goal is to solve for A, we need to undo that multiplication on the right side of our equation. So to undo multiplication, we will divide. So we're going to divide both sides by the sine of 82 degrees. Once again, the directions say to round to the nearest tenth, so that is one decimal. You can put this all into your calculator. Make sure that you are dealing with your calculator in degree mode. And then because we are doing the sine of 64 degrees, then having to be divided, make sure you close the parenthesis for that angle before you divide by the sine of 82. When we do that, we get in the calculator 12.70677 and so on. But because I need to round to the nearest tenth, I look at that second decimal, which is 0, And that tells me that I am not going to change the 7. So 12.7 would be that side of A. The last missing piece of this triangle is side of B. So that means that we are going to still use that very first proportion. I don't want to use the side that we just found because 12.7 is a rounded value. I want to be as exact as possible until I have to do the rounding at the very end. So I do want to consistently use this first proportion or this first fraction right here. Okay, so we're still doing the 14 over the sine of 82. This is going to equal, we now want to find the side of B. So that means that now we need angle B, and that's what we found at the very beginning. That's a 34-degree angle. So we are going to cross multiply like we did above. So once again, the 14 is going to get multiplied by the denominator in the other fraction. So that is 14 times the sine of 34 degrees. This is going to equal then b being multiplied by the denominator in the first fraction, which is the sine of 82. We want to get the b by itself. So once again, to undo that multiplication, we are going to divide. And then we are going to carefully put it into the calculator and we will round. So 14 times the sine of 34, close the parentheses, divided by the sine of 82. In the calculator, we get 7.9056 and so on. So once again, that second decimal is a 0. That tells me that I do not want to change the first decimal. So our side length is 7.9. If you remember from geometry, the smallest angle should be across from the smallest side. Notice that angle B, it was the smallest angle. That was 34 degrees. Notice that the smallest side length is that 7.9 that we just found. So same idea with the biggest angle should be across from the biggest side, and then the medium-sized angle across from the medium length side. So there's always that relationship there too that you could double check and verify. Okay, let's look at this. Notice that I don't have a picture already sketched for you. So if they're asking you to solve triangle ABC, I would suggest that we just sketch a picture, fill in our information, and then we can go from there. So I'm just going to label the triangle ABC and start filling in my information. So they're telling me that angle A is 40 degrees. We've got angle C to be 22.5 degrees. And then side B, which remember is across from angle B, that is 12. So notice that in this situation, that side is in between my two angles. So we have an angle side angle situation. And that's why we are going to be thinking about using the law of sines. But we need to find the 3 missing pieces. Notice that I'm giving you 2 angles. So right off the bat, we should be able to find that third missing angle. So I'm going to take that 180, and then 40 and 22.5 need to be subtracted from it. When we subtract, we get 117.5 degrees. So notice that obviously the picture that I sketched doesn't truly represent what that angle measure is. I don't really care what the sketch is. That just helped me see the situation of it. So I knew because it was angle side angle, I'm going to be using law of sines. Eventually, we're going to have other situations where maybe we have to do other types of things. So just having a quick little visualization there is going to help us out. Okay, so now that we know what angle B is, that is going to be super important because we only know what the side of B is. That means we want to find the side of A. And so in order to do the law of sines, we have to use that side of 12. And so then that has to be divided by the sine of the angle B that we just found, which is 117.5. If I want to find A, I'm going to set that equal to A over the sine, and now I want angle A. So that was my 40 degrees. So because it's a proportion, we are going to cross multiply and then begin solving. So we will have 12 times the sine of 40 degrees to equal a times the sine of 117.5 degrees. To get that a by itself, we have to divide by the sine of 117.5 degrees. Then we'll just be very, very careful typing it into the calculator, closing our parentheses before we do our division. We once again want to round to the nearest tenth, so my calculator is telling me I have 8.69600 and so on. So notice that second digit was a 9. That is going to round that first digit up. So we should have a length of 8.7. The other missing side we want to find is C. So once again, I'm not going to use my rounded number of 8.7. I'm going to go back to the original ratio, 12 over the sine of 117.5 degrees. So I'm using that. Now I want to find the side of C. And so I have to divide by the sine of that angle, which is 22.5 degrees. So cross multiplying. Notice how we want to multiply 12 times the sine of 22.5 degrees equaling C times the sine of 117.5 degrees. So we'll divide by the sine of 117.5 degrees. And then we will have C by itself. So in our calculator, we have 5.17716 and so on. So I look at that second decimal, which is a 7. That tells me I want to round the 1 up. So we get 5.2 for that side. Once again, if you look at the measures of the angles versus the side lengths, the angle B that we found was the biggest angle, 12 was the biggest side. 40 was the next biggest angle, 8.7 is the next longest side. Angle C is the smallest, side C is the smallest length. Okay, so that's us using the law of sines to solve oblique triangles.